All right, good morning. We covered, basic 4, 5, 6. And with those in mind and the basic properties of absolute value functions and the different aspects we have covered. Today we're gonna, just cover basic 7a and then we're gonna move on from there. Do you guys have any questions? Any questions? Okay, if you don't have any questions, let's look at 7a. 7a is really, what we have covered yesterday, right? There's a perspective that related to numbers to 7a, right? So here, so let me bring back this table. Let me bring this table to the top. If you understand these categories, right, these three types, and also you understand the basic facts, right, the absolute value of x greater than or equal to 0. We know how powerful this statement is, right, for any real number x, right? We know this is a very powerful statement. There's a lot of implications. There's a lot of implications in that statement. And there's these three types, right? These three types. And then basic 7a would just basic, in basic 7a, what happens is that all of these x turn into bologna, right? In basic 7a, we see that, say, for example, the first question, right? So I'm gonna give you the perspective. The first question, which is a 5x in absolute value less than 20. How would I see this? I would see this 5x as just one symbol. 20 is in similar row to 3. So omega less than 20, these two questions are similar, right? i.e., you just see this as omega now. You know what I mean? So x turned into bologna. Then you follow the same setup, right? You follow the same setup, and then you will solve you probably will take a couple more steps to finally solve the x, right? So let me show you what I mean by that, right? So instead of seeing x as what we saw before, now our omega is in the place of x. So x turn into omega or turn into whatever you call it. I call it bologna, right? Now, all of these will be true, right? All of these situations will be true. It's just x turning into bologna. In our situation, when this is 5x, right? When this is 5x, what do we get? The next step would be negative 20 less than 5x and less than 20. So 5x is between negative 20 and positive 20, right? So it's a basic 5 type. And then you would divide both sides by 5. When we divide all three sides by 5, we get negative 4 less than x less than 4. Then you're done. Right? Or you can also do it this way. You can also do it this way. Okay. You could do it by taking out the 5 because the absolute value, okay, the absolute value of 5x is the same as the absolute value of 5 multiply the absolute value of x. So absolute value of 5 is 5. As a result, if this is true, then 5 times absolute value of x will be less than 20. And then you divide both sides by 5. You end up with absolute value of x. That'll be less than 4. So in the end, you still get the same answer. Okay, so this table we have here have the 3 types, right? So all the questions you're going to encounter is going to be either using this one sentence, powerful sentence describing domain and range for absolute value function, or you can utilize one of these models to resolve the question, Okay, so with that said and done, I want to give you guys some time to practice. All right. I think Farouz is here, right?
Yes, Professor.
I know he's here. So let's practice. Okay, practice to see how we get to utilize those, what we learned yesterday. Okay, practice makes perfect. Huh, wait. PR, what's going on here? PR, okay. So practice. So let's choose. I'm asking you to choose 3 questions. Okay, arbitrarily. Okay, and I work on them. Okay, and I will have the breakout rooms available. But if you stay with me, I will let you do it a little while and then I will take your questions. Okay, so now I open the room. If you want to work with Farouz, go for it. If you want to stay with me, I will let you practice a little bit. Just make your choices. I want you to pick the question that you think might be a little bit difficult for you. Okay, so the 3 basic types, okay, with all the stories behind it, right? With all the stories behind it. Okay, so here, I'm gonna still use the X here and makes that, okay, so absolute value of X less than 3. And that turn into baloney. And this piece larger than 3. And that turn into baloney. Okay, so with that said and done, and you work with the inequalities, right? That's how to show the work, right? And also we have similar scenario that turn into baloney. Right? That turn to baloney. And that turn to baloney. You guys understand what I'm talking about, right? And of course, the absolute value of baloney is what? The absolute value of baloney is greater than or equal to 0. Always. Okay, so you have that. Okay. So these are the 3 models. Okay, these are the 3 models. Okay. have the 3 models. Okay, let's go. Let's do it. I'm gonna refill my cup and I'll be right back. How's it going? How are we doing? If you wish to submit your work, you're welcome to do so. If you wish to submit your work, How's it going? Okay, guys, I'm coming back. Okay, so let's go over some of these questions. Okay, let's go over some of these questions. Let's see if let's wait for them to come back. Okay, welcome back. Okay, So for those of you who went to Farouz's room, if you have done, I think he has done 2x in absolute value is larger than 7, right? So I'm just going to bring that issues over here. Okay, and you guys, have seen that. You would, excuse me, just for a few minutes. I'm going to go over this question. That 2x in absolute value is larger than 7. Remember, okay, I always want you guys to be aware of the kind of sentences this is. Okay, so I've been doing this over and over, but I still can't help. I have to remind you. This is an if statement. Okay, this is an if statement. Okay. It says if the absolute value of 2 times an unknown number is larger than 7. That's what it means. If, it's an if statement. Because it's an if statement, okay, mathematical principles that are related to if statement can be used. That's why, right? And of course, in this case, there are multiple ways to do it, right? If you set up directly according to this model, which this is the model that's fitting for our situation, you will have 2x less than -7 or 2x larger than 7. I'm going to explain to you why we prefer they are on the same row. Why we prefer they are on the same row, okay? And I will show you the preferred way of doing it. And then I'm going to explain to you why when you break it to different rows, sometimes it makes the reading not as fluent. Okay? Now, if you do it this way, when we solve this inequality, right, just be reminded that this is the if statement. Of course, we can put that on the side, right? And then you will have, basically when you read it, is that this is how you read it. If this is true, then this is true, or that is true. That is how we read it. Do you guys follow me? So from line to, when you read mathematics, because it's a highly shorthanded, right? There's so many shorthand notations. So you have to insert those words in your mind when you go through the steps. Do you guys follow me? This is what I spend time and energy to emphasize. Because if you don't fill in those words between the lines, soon enough, nothing makes sense. Okay? Let me tell you the truth. If I don't fill in those words between the lines myself as a teacher, soon enough, I will be losing track of what I'm doing. Do you guys follow me? So as a teacher, I need that. As a student, you need that even more. So you must be engaged in the process. But how do you read it? The way we read these mathematics actually is very boring. Okay? It's if. And the next line is what? The next line would be then. Okay, so the way you read mathematics is like this. Okay, so if I'm going to put the words in between. Okay, so see, to show you. This is basically say if, right? Then, okay? And then we say if, then. And what will be the then? You're going to have x less than -7/2. Or you can use 3.5 if you wish, or x is larger than 7/2. And that will be the answer. This latter one is the answer. So if you are to fill in those words in mathematics, this is how they should be read. If this is true, then this is true. If this is true, you can see this repeat, right? And then the next will be true. Do you guys see that? If you are to write them in those details, you know, in the mind, but unfortunately, mathematicians make this short. Okay, how did they make it short? They remove the word if. They remove the word then. But you need to have those words in your head. Do you guys follow me? And if this is true, then, right? And these two repeats. So we saved it. So you just have 3 lines. But in between is if then, if then, if then, if then, if then. Mathematics, when you solve inequalities like this, how do you read it? You always, forever read it this way. The words is not there, but it's in your head. So if then, if then, if then, if then, if then, forever until you finish that question. Do you guys get it? But we make it shorter. We make it shorter. But in your head, you need to say, okay, if this is true, okay, hold on. In your teacher's head, in my head, this is how I read it. If this is true, then this. If this is true, then that. So when I grade your work, what do? I will say, okay, I will be judging if this is true, would that be true? So when I grade your work, I'll be asking this question. If then, is that correct? So that's my question. If that's correct, you get the points for that step. Do you follow me? Now, if this is the if then, and I will be making that judgment call. Is that correct? This is how we check you step by step. Do you follow me? So every step has to be sound. Suppose I make a mistake somewhere. Suppose, I make a mistake somewhere and there's a broken link between the step prior and the step after. And you're gonna lose all the points after. Do you follow me? If there's a broken link, then logically, you can skip steps, all right? But if there's a broken link that it's not judged true, okay? So if I judge this piece as correct, if I judge that piece as correct, you get the points for that step. If you get that, if you judge that correct, if all these question marks are confirmed to be yes, then you get the step, you get the points for all the steps. And for the shorthand notation, I do the same way. Okay, I'll be asking from this step to the next step. Question mark. Is that true? If true, you get the points. And from this step to the next one, I will be judging again. I'm not judging you as a person. I'm judging your work. Okay, that's my job, to judge your work. And then if that is true, you get the point for that step. That's why you need to write coherent sentences. You are writing, I would say, like a, book report or some essay or something. For that reason, right? Go back to what I was in the breakout rooms of, Farouz's breakout rooms. If you write it this way, okay, if you write it this way, from 2x, absolute value 2x greater than 7, right? I did see people write it this way. People will write it, okay, 2x less than 2x less than -7. Okay. And then the student will do the following work. And they put the or later. What do you think of that? If you separate them, the reading will not be as fluent. Do you agree with me? Do you agree with me? At least I see it that way. If you break them into two pieces like that, because we read from left to right, top to bottom, right? Do you agree with me? I don't read this way and then I read it that way. No, I read it from left to right, top to bottom. That's how I read your work. Do you follow me? Okay. So this way, is less preferred because the reading is not as coherent. Okay, so this is why this piece is preferred, and this piece is less preferred. When you read it left to right, top to bottom, you read this awkward. It's awkward. Do you agree with me?
Yes.
Okay, this is why I said I was telling that group, write it horizontally because you read it from left to right. So when I check your work, I would check that if this is true, the next statement has to be completely, this next statement has to be completely agree with this if statement. It's just a different way of saying it. It's just a different way of saying it. Is that clear?
I see, Professor, from point of computer science, the answer must be in one line.
That's right. That's right. Okay, so your sentence, remember, your work is read from left to right, top to bottom. Just like I would read your essay. You just use a lot of shorthand notations in your essay. And sometimes I see people doing this, right? They have many lines in between. They have from here, they will have this, and then they will leave many lines in between because sometimes it needs more steps. So this kind of work is very awkward. It's very awkward. It's like you say one sentence, you say half of it, and then you start saying the next sentence, and then you come back to the first sentence. It just doesn't make sense. It just doesn't make sense to me. Okay, so the best principle for you to follow is just follow the preferred way. Okay, you just follow the preferred way. Do you guys get it? So number one, how you read your work, how your teacher read your work. That's how I read your work. This is how I read your work. Just if then, if then, if then, if then, if then. If that work takes 10 steps, you're gonna have, 10 if then. Your work is gonna be read if then, if then, if then, if then. And there's no other ways of reading mathematical work when output is given looking for input. So mathematics, if you look at the grammar, it's pretty boring. There's not a lot of variation. Not only there's no future tenses, there's no past tenses, and there's no could have been, should have been. They don't have these things. Just one tense, present tense, because all the math you do is meant to be right forever, for eternity. Okay, the math you do today should be right. If it's right today, it should be right when you see your grandchildren. You follow me? and the logic and everything should be just right. Okay. All right, so with that said and done, is how to write, what it means, how to read. And this is how I mainly want to tell you, this is how I read your math, always. So my work, you can see, is pretty boring in a way. Okay. In my head, when I read it, just if then, if then, if then, if then. If there's one broken link, everything else after is nullified, annihilated. Okay, it's like you're building a building, right? You have your foundation, you have your first floor, then you don't have your second floor, and then you're building your third floor. How is that possible? That's not possible, right? You can't build your third floor without second floor, right? So that's mathematics. That's mathematics. And every step has to be sound and logical because every step is judged. Every step is judged and questioned. Okay, so I hope I made myself clear, and I hope that this speech is not too long for you. So now, this will be the piece of work that's preferred, right? As you understand. This is the preferred. Okay, now let's take some other questions. Do you have a question? Do you have a question? Anybody want to submit your work? Because I'll be happy to critique it. I hope you're not scared, right? If you don't like my criticism, but I'm criticizing your work, I'm not criticizing you, okay? Be aware of that. I would appreciate those submissions, and so I can, if I see some common mistakes, I will not hesitate to do it, to criticize, to show you, okay? To let you know. Do you have any questions? Okay. If you don't have any questions, I have questions for you. Because I want to point out some common mistake. Okay. You can see that we have these three types in general, right? These three types will take you a long way. And of course, we also have this nice properties here, and the absolute value of anything is at least 0. That's always true, right? So in most of the cases, you'll be applying these three types or applying that, like the example we've done before. But sometimes I see these kind of mistakes. Okay, very common, very, very common. Okay, take an example. I'm taking number 6. Okay, so absolute value, x plus 1, greater than or equals to 1. Okay, and this student, sometimes the student will forget this is absolute value, right? When you apply the 3 models, you're going to drop the absolute value sign. Okay, you're going to drop the absolute value sign. So this student might be doing this, right? So this is x plus 1, right? It's going to be less than or equal to -1, or doesn't matter which order though, greater than or equals to +1. So this third model applies here, right? Do you guys see that? Does everybody follow me? This is the right way to do it. Okay, I will show you the wrong way to do it after this. Okay, so x is less than or equals to -2, or x is larger than or equal to 0. Then you're done. you're done. If I were to grade your work, this step, this piece worth 1 point, 1 point, 1 point. Okay, so this piece, we have 3 points. Okay, the next step typically would be 2 points. Okay, that's a typical way I grade your work. Okay, here's the common mistakes. Common mistakes. Sometimes people leave it blank. If you leave it blank, this 2 points is questionable. This 2 points is questionable. And this 2 points is also questionable because I will have to look through your work. I'll look through your work if you understand that this should be or. Because when you leave it blank, that leave a question in my mind. Does this student know this should be and or? Okay, so that's how you leave it questionable. If someone put an and in between, you get a 0. That's how important these 2 words are. Okay, so during my lecture, when I speak of these words, if you listen carefully, I should be saying the right word. If I said the wrong word, you should hear it. Okay, so if you have this and of course this will become and, right? You get a 0 for the entire question because there's no number that can be less than or equals to -2 and at the same time greater than or equal to 0. So this means there's no solution. This means there's no solution. When you said that, there's no solution. So that's how important this word is. Do you get it? Do you guys get it? And or as referred to the truth table. I mentioned yesterday, the reason I introduced truth table at the very beginning is exactly for these situations. Exactly for these situations. Mathematics is not about numbers alone. Mathematics is about logic. Okay, it's training a logical mind. If you can't even have and or clarified, you're doomed to make a lot of mistakes. You're doomed to lose a lot of points. Do you guys understand? Okay, so in this case, if you have everything in place, but you use the wrong word, you're gonna get 0. Okay, if I'm to grade your work, if I'm the person to grade your work, you're gonna get 0. All right, no question asked. Because no matter where you go, you talk to the dean, you talk to other professors, everybody would agree with me. Everybody's on my side. Every teacher is going to be on my side. Okay, that's how important and or are. If you leave it blank, as I said earlier, you say, oh, I'm not sure it's and or, right? You leave it questionable. Questionable. So this is going to be a questionable, is this going to leave a question mark in my mind when I grade your work? And I will try to find clues through your work if you have much work to show. If I will be looking for, if you leave it blank, first of all, you're not going to get all the points, right? You're going to lose 1 point already, lose 1 point here, lose 1 point here. But I still have question mark in my head. Does this student understand it should be or this student actually think is an and. Of course, I'll be looking for evidence that you think it's and. Once that evidence is confirmed that you think it's an and, you also lose more points. So you can see how important it is to really understand these models. Do you follow me? Yes? Very important. Okay. Another mistake, which is also very common. Okay, so mistake number one, mistake number two. Another mistake is very, very common. So here it is. This student would create a situation he might like very much for himself. We see this mistake all the time. He basically saying, okay, it's hold on. It's this model, right? He recognizes this is the model. I'm sorry, these two models, right? These two models. So let me bring it over here. The student recognize these two models, no problem. Right? Larger than you, and they combine these two. They change this, oh, less than -3, so less than -1, next then less than equal to -1, and greater than 3, so greater than equals to 1. What do you think is this? What do you think this student has done? This is a popular mistake. This is a very popular mistake. I've seen it. Okay, I've seen this when I was a TA before I graduated with my degrees at USC, when I was grading my students' work. I've seen this every single year, every single semester when I'm teaching in my entire teaching career, 20 plus years. And I also taught at 2 other colleges before. I've seen these mistakes rampant. What is this supposed to mean? Tell me. We had a lecture yesterday, right? We talk about when we put, inequality sign like this in links like this. What is this supposed to mean? Does such a number exist, that this number, right? No matter what it is, we see this as a one number. Right? Do we have a number that's less than and equals to -1 and greater than equals to +1 at the same time? Because once you put them in this link, it will no longer means or, it means and immediately. Yesterday we talked about only for and situation we can put them in that link in the same direction. When you put it this way, you change or to and. What do you get? What do you get for this step? Okay, you get 0. And what's more interesting about these students is that they will do this. They will do this, right? That's even more hilarious. Okay, they will do this, right? And after they've done that, and this student will get -2 larger than equals to x larger than equals to 0, right? They get this. I don't know what's going through the student's head, right? And of course that should be 0. And then very interestingly, the student will turn around and tell me the solution is less than or equals to -2 or x is greater than or equals to 0. What do I do with that situation? How do I give points, taking points away in this situation, right? Because I see this all the time. I have to have a policy to grade the student fairly. Very common mistake. Okay, so this is how I'm going to grade it. Remember, we read from left to right, top to bottom, right? Left to right, top to bottom. Okay, so that's how I'm going to read it. So from this step to the next one, you get 0. From this step, because you're reading is if then, right? So if then here, that's wrong, plus 0. If then from here, that's wrong, plus 0. And then the next step, I will be judging from here, do we get to be here? Plus 0. So oftentimes the student will come to the teacher and say, I got the right answer. I got the right answer. But from the way we read the mathematics, your answer is not supported by your steps. Your answer, even though you got the right answer, but your right answer is not supported the right step, does not support your, is not supported by your steps. Therefore, you're not getting points. You're not getting points. Do you guys understand that? So it has to be logically sound on every single step. That will make your work immortal. Okay, that's what makes your work immortal. Then you say, hey, I don't care about my work is immortal. I'm not a math major. I just want to get some points. I want to graduate. You know, I just want to finish my requirement. I know, I understand that. But your math teacher still have to grade your work according to mathematical principles. Okay, do you guys understand that? Just don't do it. Don't do it this way. Do you follow me? You're going to lose a lot of points if you do it this way. This is a super popular mistake. Terrible. What a mess. Okay? Because you cannot change and to or. You follow me? You cannot change and to or. And or are completely two different operations, two different logical operations. Do you follow me? So never, ever. So never, ever show your work like that. If I have any parting present for you, which I'm going to, be on leave on Wednesday next week. If I have any parting present for you, that parting present would be make sure you understand the meaning of every single step you put on paper. You understand the meaning, then once you understand its meaning, its true meaning. If you don't understand that meaning, you should ask your teacher. If I write it this way, how would you interpret it? Sometimes you have to ask the right question, right? Because when we teach math, we do interpret your steps in a certain way. We do, according to the grammar of mathematics. Is that clear, everybody? All right. Okay. So this is a common mistake I've seen over and over again. Okay, but this semester, because of my medical leave, I probably don't get to see much of it. I just want to warn you. I just want to warn you. Okay, I've seen them too often. Okay, just because it's popular doesn't make it right. It's never right. Okay, so this kind of work, if you ever shown to anybody, it should be 0. It should be 0. Okay, now, so let's look at some other exercises, right? Shall we try number 7? Shall we? What have you tried? Is there any exercise you want me to do?
Yeah, could you show how to do 7?
Okay, number 7. Okay, you must understand how we read your work. Okay, so I make my grading very transparent to all of my classes, how I read your work. So now, number 7. Number 7 goes like 3x plus 2 less than 4. Apparently, it's the model here, right? This is the model that's most fitting, right? That's the fitting model. And what do I do with it? You don't need to show this to a professor. You don't need to show it to the teacher. You need to have that in your head, okay? So that's my baloney, and 3 is replaced by 4. So the next step I will show, so you're gonna see -4 less than 3x plus 2 less than 4. So if this is true, then that is true. Okay, you understand the pictures, the graphs, and everything. Okay, and then, so when you do this, if I'm teaching your class, this is 3 points. This point is critical, 3 points. And then I subtract 2 on both sides. Then I get -6 less than 3x, right? -2 on every side. That's a 2. Subtracting 2 on every side and divide by every side by 3. So I get -2 less than x less than 2/3. I'm done, finished. That's the kind of work I wish to see from my student, right here. That's the preferred work. Is that clear to you? So I've shown you the preferred work in both cases, larger than, smaller than. And yesterday we have all those other cases. So do you guys want to try some more? How about you guys pick some more questions from 7A and try them? Okay. I'm going to give you, how much time do I give you?
Professor, comment? Showing this work for number 7 and comparing with the previous question, this autopilot, you call it, it does work when we have less than symbol.
Less than, yes. Less than is this model.
Yes, but it doesn't work for the greater than.
Greater than is the other model. You follow me?
And that's why the students go autopilot on the
Less than, greater than. That's why at the beginning we were talking about these pictures. We're talking about these meanings. If they're if statements and so on and so forth. You guys follow me? For example, on 3x minus 4, how is this situation fitting in this situation in that here? Well, this is going to be the baloney, right? This time is less than 4, right? So your baloney is between -3 and +3 exclusive. So now it's a 4. It's a 4. It's just this is a 3x plus 2. Do you guys see that model? But you also need to understand the baloney is between -4 and +4. And the picture, related picture will be, this will be the 4. This will be line 4. And between -4 to +4, but about that omega. You follow me? Does that make sense? Or you want me to go in details?
That's fine, Professor.
Yeah,
Thank you.
so these are, so when you do this, when you do these model, you're doing this autopilot, you must be aware. You must be aware that all of these concepts that's related to it. Okay, in this big table, right? We did a function perspective, the number line perspective, and they're condensed into these 2 steps. They're condensed into these steps, and you have to learn how to use inequality signs properly. Okay, and in this case, the same thing. You need to understand the picture. A lot of students, they can graph these pictures. They can graph this picture, they can graph this picture, but they cannot use an inequality sign. It's the inequalities that's most useful to you. Your professor will be looking for it. They're looking all over your work to look for that correct inequalities. That's the way it is. I'm sorry, if you want to get points from your math professors, that's the way you do it. That's what I'm trying to tell you. I'm trying to tell you what we're looking for. You got the graphs, that's great. But you also have to know the inequalities. This is the and, and this is or, and the or cannot be turned into and. Do you follow me? If you mix up and or, you're gonna be confused and your professor will be confused. You know the consequence when your professor is confused, guess what will happen? We take points away. So it's essential for you guys to understand these pictures. That's why we covered these pictures at the beginning and related to it, right? They all mean the same thing, right? For example, in this case, right? This line mean the same thing. They mean the same thing. They mean the same thing. They mean the same thing. And they mean the same thing. It's just different forms. And which form will be eventually earn you the points? This one. Am I clear? Am I clear about it? I have no doubt. Probably 99% of you can do these pictures correctly. But I'm not sure it's going to be the same percentage. I'm not sure it's going to be the same percentage. I'm sorry. Okay. I'm not sure it's going to be the same percentage when you need to use the inequality. That's how the students in calculus class, they lose points left and right. That's how I see those popular mistakes. Right? I saw those popular mistakes. Every single semester, no exceptions. If I once told my class, if you don't make these, if you guys can score these perfect scores, I'm gonna buy pizza for you. I never have to buy the pizza. I do have I have my money ready for it, but it just didn't happen. Okay. So from my perspective, I earnestly wish you to understand my intention. My intention is for you to get the perfect score. Yeah? Do you have any question and any doubt about that? Yes? No? Do you have any doubt about my intention?
No doubt, Professor.
No doubt. I have no doubt. I have no doubt about myself, right? Out of my conscience, I want you to score perfectly. That's why I want to point out these common mistakes. Okay, so I want you guys to practice. As Farouk said, practice makes perfect, right? If you never touch a paper pencil to do these things, and of course it's rusty, and of course you're going to make mistakes. So I'm going to have you guys to choose the question of your preference, okay? You choose the 3 questions, or however many questions. We don't have much time left. We have 27 minutes left, right? So you choose whatever question you have. We have the models here, we have the basic principles here, and we have all the examples here. I'm going to give you 10 minutes. How about 10 minutes?
Sounds good.
Sounds good, right? And I'll be right back. I need to turn off that microwave. It's beeping at me.
Okay, any question while we are waiting for Professor to come back? Unmute and let each other know. I came up with very interesting question. I wonder if any of you guys also came up with what I have question for Professor from solving this kind of inequalities. Anybody, any suggestion? Sorry, here was too noisy. I had to mute it. So any suggestions, any idea? Practice makes it perfect, better, faster, therefore easier next time when we see question like that on the next quiz, exam, final. Any suggestions other than practicing more of this type of inequalities? So I don't know. I don't want to just say it. I'm trying to see if you might see a question like, inequalities, then they might say, and graph it. After, finding the solution, solving it, then graph it. So remember visualization, picture word, 1,000 words. Maybe by visualization, the next step, by graphing inequalities, then it helps us to understand even more. As Professor corrected me, as a computer science background, I have to write my answer in 1 line and use the right wording like or. So now, Professor, while you weren't here, I came up with very good suggestion, our question, and I was wondering if the class is thinking the way I came up with after solving this kind of inequalities. Then I remember they used to tell us the inequality is the region. It's the equation. We say the solution and all those things in the previous classes we learned. Therefore, what if you give us question like number 6, we see it on the screen, and then you say, okay, solve it, then graph it. If you want to graph inequality, is that such a question like that on the future quizzes or exam, graph inequalities?
If you're graphing inequalities, from here, you already understand this is the, you mean graphing the solution, right? You mean graphing the
Yes.
solution? If you are asked to graph the solution, right? You need to understand this will be corresponding to 2 intervals. Okay, so I will show you how to graph that solution.
And also we know the basics, the absolute value function is a V shape, therefore greater than 1 or less, all those has
Right.
to correspond to the V area inside the V shape.
Right. There are 2 ways to graph this, right? You can graph it this way. You can graph it this way. If you graph this solution, so you can use a one-dimensional to graph it. Okay, there are
Yes.
different ways to graph it. This is the most popular way, the most common way to graph it, right? Less than equals to -2. So you're gonna mark this point as -2, right? That's -2, and less than or equals to -2, right? So you're gonna have a dot. Okay, you're gonna have a dot. You're gonna have a dot here. And then you're gonna mark your red over here. Okay, so this piece, right? Wait. Just this piece to -infinity, 0, right? So you're gonna mark 0, right? You're gonna mark 0, including 0. So you're gonna mark the other piece. Okay, you're gonna mark the other piece. So this is gonna be a circle, solid circle, and then you're gonna mark the other interval. Wait. Okay, you're gonna mark the other interval. You follow me?
Yes, as you said, this is a one-dimensional representation,
Right.
but when we superimpose this into the V shape, that becomes wonderful and understanding becomes complete.
Yes. So the other way to mark it in our context, because we introduce the mathematical, we introduce the function perspective, right? So this is the function perspective. Did you guys write this down? I'm going to clean that up. I'm going to clean this up. Okay, because if I'm moving up and down, it's still going to mess up. You get it? So this is one way to mark the solution. In our situation, however, right? So you will look at this function, right? So this is our new function. This is our new function. This function is no longer at it's basically f of x. Okay, it's a composited function.
Shifted to the left 1 unit.
Right, it's a composite function, but it's shifted to the left. It's shifted to the left, okay? You can get the graph at your fingertips, or you can also plot points. You can also plot points, okay? So suppose, I'm gonna talk about plotting points in a minute, okay? So this graph is shifted to the left. There are different perspectives to see this, okay? They're different. So I'm not gonna do that part yet. So over here, so that's the graph. That's the graph, right? That's the graph of the function. Then it's being shifted to the left, right? So then you say, how do I know it's shifted left or right and so on? So we'll get to that, okay? We'll get to that later. Greater than equals to 1, right? So this is the graph. F of x is, input is x and the output is absolute value of x plus 1, right? So that's the story. but it's still a rule, right? This is still a rule. This is the rule of the function. The rule of the function says I'm going to take the input, I'm going to add the input with 1, okay? And then I'm going to take the absolute value, and then produces the output. So your output is absolute value of x plus 1, okay? So that's the rule of the function. So you get this graph. For this graph, it's a greater than equals to 1, greater than equals to 1. So I'm going to have the output equals to 1, the red line. Okay, greater than equals to 1. What input will give us the output greater than or equals to 1? What are they? These, right? Oh, that's too thick. Sorry, too thick.
From 0 to positive.
That's right. From 0 to -2, right? Outside 0 to -2. So you're gonna have these pieces, these input. Oh no. I need some artificial intelligence to help me. Okay, so when your input are chosen from here, right? If your input are chosen from there, those outputs, okay, the output you can see is a higher than 1 or equal to 1. This is equal to 1. This high output is equal to 1, larger than 1. You can see these output are all higher than the red line, right? So these output are larger than 1. Do you guys understand? So these output is equal to 1, and these output are larger than 1. So that's the meaning of the solution. So those inputs will cause the outputs equal to 1 or larger than 1. Does that make sense?
So inside the V shape, the imaginary line from 0 and -2 vertical lines, border lines, then shaded area corresponding to those solutions, shaded area. I mean, the area.
Yeah, these are the inputs, right? These are the inputs, right?
Yes, yes.
These are the inputs. I should be using crossing, okay? I'm gonna use all these are little inputs, okay? Inputs. And that's the output. Still the same idea about input, output, okay? So let me show you. So each point, for a point on the line, the input is, this is the input. I'm going to use a thicker green. That's the input. Input is a horizontal measurement from the origin, and the output is that. And we want the output to be larger than 1 or equal to 1. Does that make sense?
Yes.
That's the V shape. The picture I drew earlier, right? Oh. The picture I drew earlier on the one-dimensional, okay, is basically emphasizing the input. Okay, it's emphasizing the input. We just emphasize those inputs. Okay, we emphasize those inputs. Those inputs. Oh, I should be using a different color. Jesus. Sorry about that. I might kind of. Okay, so I'm going to use a different color. Okay, that's the number 9. Right? So that's a 0, that's a -2. -2. So the solution would be all of these numbers. So it emphasizes the input only without considering the output. You follow me? Basically just showing the number line. So these are the two different ways of showing the picture. This way is often not taught. This way is often not taught. So this way was taught more.
Yes, maybe,
Agree?
yeah, maybe I don't want to take class time much, but in a intermediate algebra, maybe that's the last part of my question. In an intermediate algebra math 80, we used to graph, equation, then inequality. And then when it came to inequality, comparing with equation, graphing it, the equation would create the borderline in the XY axis. And then inequality would, using the test point in order to find the true region for shading above or below or that borderline. So that is something shading.
That's something else.
Okay.
That is for the two-dimensional. Okay, that's for two-dimensional linear situation. That was taught in intermediate algebra.
All right.
What we're doing here is the solution is in one-dimensional. Okay, and
Yes.
it's in the concept of function, input output. In this other form, when we see it, we talk about it. How about that?
Okay, sure. Thank you. Thank you for
Mhm. We do have those exercises in the packet, in our notes, but I think I don't want to confuse people at this point.
Definitely, yes.
Yeah.
Thanks.
Mhm. Is that clear, everybody? Or are you more confused? If you're more confused, I'll be excited because I can help you to clarify. You see those questions on 7A, 7B. Some of the questions on 7B actually will be the question you are going to see in calculus. For example, number 9 on 7B will be a typical question you might see in calculus. I say you might see, depending on how your instructor proceed with those kind of issues, but I'm not going to touch it. I'm going to save those for your calculus instructor. Okay, but if you look at number 3 and number 5 in 7B, right? Those are similar to what we did. But I'm going to leave it for you. I'm not going to, make that. If you're curious and you have time, you want to study 7B, and I'm sure you're gonna learn much. Okay, so you can bring questions to me whenever. Okay, so 7A, we have 10 minutes left. 7A. Do you want me to cover how it's been shifting and so on and so forth? You just plot points. Just plot points, you see it. Okay, just plot points like we plot points for the absolute value of X. Remember when we plotted so many points when we did basic 1 table, right? Did you guys remember we plotted so many points? If you just do those things, you just do that, and I would say maybe boring things, you see everything. You see all the devils in the detail. Okay, I'm gonna leave that for you for the moment. You see, if you really bewildered by that graph, okay, after you think about it, come back to me. I'll be happy to cover for you. Okay, so 7A. Any other questions you want me to do before we close today?
Could you do number 10?
Sure. Number 10. Number 10, we got the absolute value of 8x plus 3 larger than 12. So this is my model, and all the pictures comes with it, right? All of these comes with it. I'm bringing this along. Okay, hold on. All of these. Okay, you understand the picture and everything, right? Right there. Okay. And our our omega is 8x plus 3. 3 turning into 12. You guys get it? And then you proceed from there. Okay, you understand all of these situations, right? It's outside and so on and so forth, right? Now you can just set up. You can just set up. Okay, so I'm gonna put this on the side, on the top. With all those understanding, we're working on number 12. Okay, so 8x plus 3, that's my omega, that's a negative 12, or 8x plus 3 larger than 12. And then you subtract 3 on both sides, right? If then, that's how we read it. So 8x less than negative 15. Or 8x larger than 9. So in the end, we get x less than negative 15 over 8. Or x is larger than 9 over 8. That's it. That's what your professor like to see. That's what we love to see. Is that clear? So what do you think might be bothering you? The fraction? You can clearly see this is the same model, right? You can clearly see this is the same model, right? Right? They're the same model, aren't they? That's omega. And 3 is replaced by 12. Right? Does everybody see that? Yeah. If you encounter negative numbers, then you have to think about it, right? Like like those examples we covered yesterday. Okay, so those are the same models. So now, did you get it? Do you guys get it? If you ask to give the graph solution, okay, that's, let me see, there's a comment on, can we go over number 2 on 7A? Is this a question just now? Or number 2, is that okay? Sure, number 2. Just let me finish this, okay? If you are to graph the solution on number line, guess what I would do? I would do this, okay? My number line, right? You don't have to be precise. You pick a point here. There's a point here. Oh, too thick. Wait. Okay. I'm going to pick a point here. That's my negative. As long as you get the negative position correct, right? Because, and here you're going to have, this is going to be your negative 15/8. And the other one is going to be your 9/8. Right? So less than, so your solution will be less than, oh, I'm kind of awkward. That's a solution. And that's the solution. That's the graph. And usually that's sufficient. You don't have to do the V shape. You know, you don't have to do the V shape. You guys get it? So this is easier. That should be sufficient. Is that clear, everybody? If you still want to do the graph, then yeah, you have to plot some points and get a graph. Do you want to get the graph? The V-shaped form? The idea is the same. The idea is exactly the same as the one we did earlier. It's just you want the output to be larger than 12. The output want to be larger than 12. Same idea. Completely same idea. Okay. Right, larger than 12. Larger than 12, so that's 12. So we want inputs that are, so you identify these 2 points, right? These 2 points. There's a point here. Oh. There's a point here. There's a point here, right? And those inputs, right? These inputs, this point is going to be negative 15, 8, comma, 12. And that point is 9/8, comma, 12. And you want to be larger, so your solution would be all of these, all of those, but you may like to show your little circles over here. Okay, that will be the picture on the V shapes. Okay, and all the outputs, right? All the outputs, they're larger than 12. They're larger than 12. Does that make sense? Same meaning, no difference. So Christopher asked me to do number 2 on 7A, not a problem. So let's go there. Okay. Number 2. Number 2, we have absolute value 16x less than equals to 8. Right? So one way you can do this, because this will be the two of these two combined, right? These two combined. So you're gonna get a -8 less than equals to 16x less than equals to 8, and divide every side by 16, you're gonna have a -½ Do you think it might be the fraction that bothers you? Is that what it is? I'm just curious. Is fraction something bothers you? You better get used to fractions. You need to love fractions. I will tell you the truth. One day you're gonna buy a house or you're gonna buy a new car. You will love fractions. You don't want whole numbers. Okay? You want your interest to be 0.05%. Or if possible, you want your mortgage interest rate to be 2.125% if you can help it. Those are all fractions. Don't you love them? Or you want a 6%, 5%. Any percentage you're going to be dealing with, they're going to be decimals or fractions. You better fall in love with them. It's related to your pocketbook. Now we don't use a pocketbook, right? Related to your account. It related to your PayPal account, related to your credit card payment and stuff like that. You better fall in love with fractions. Okay? If you have a hard time with fractions, find a pre-algebra textbook and find the chapter of fractions and just have a crash course and just sit in your closet, just do one after another. After a few days, you'll be the master of fractions instead of being mastered. You promise me you're gonna get used to fractions, yeah? Yeah? No joke. You will love fractions when it comes to payments, right? Can't promise. You must promise me. Okay, get used to fractions and fall in love with them. Okay, think about the prospect that one day you're gonna buy your favorite car, buy a house for your family. You would love fractions. Okay, if you have to choose an interest rate between 2.125% versus 100 versus 2 means 200%. Which one do you choose? You want to choose 2.125%, right? That's a no-brainer. Can't promise. No, I'm going to make you promise. How do I make you promise?
Send them to Math Study Center, Professor.
All right. So, right, George, you got to go to Math Study Center.
I will be there today from 6.
To meet Farouz. This is truly 5 courses in one. Truly 5 courses in one. Okay. I'm very grateful because my interactions with you, I feel that I might be of some help to you, especially before I'm going to be on the medical leave. But your interactions with me help me teaching, and I hope I have helped you learning. Okay, because 5 courses in one, sometimes as a teacher, we don't know where to start. I choose to start from the function. I choose to start from function, because if I start from pre-algebra, I will never finish. You will never be ready after, you'll never be ready for calculus. That's why I decide to choose to start from function. But how good is my choices? Right? I don't know. ultimately is your success in calculus will tell me, okay, that's the right place to start. Because we are teaching 5 classes in 1. As you said, you have hard time with fraction. That's a pre-algebra stuff, right? So you need to crush it. You have to crush it, right? Radicals, 1 over root 2, root 2 over 2, these things, elementary algebra. Crush it. We have exercise in the notes, right? Fractions, we have exercise that has been given to you. If you think you need more, get more. There's no other way around. No other way around. I wish there's another way around. Just put away your calculator and commit to your paper pencil. That's all. That's all you need to do. Okay? I will see you guys tomorrow. Have a great day.
Thank you, Professor.
Thank you, Haruz.
You're welcome. See you tomorrow.
We'll see you tomorrow.
Thank you for the lecture, Professor.
Of course, anytime. My great pleasure. I will miss you guys terribly.